Okay, so for today we actually have two topics left to finish off our Unit 1 here. We're going to talk about combined operations or order of operations with our numbers. Again, a little bit of a review from you from your pre-algebra days. If we run into things like this, 8 minus 4 times 3 plus 7. When we look at that, it's very tempting to just work on it like reading a book. Go from left to right. 8 minus 4 and then times 3 and plus 7. But that would not give us the right answer. To make sure that when two people look at a problem, we get the same answer in math, we've defined something called the order of operations. Now, the order of operations is often described as a series of steps. That's not quite true. The order of operations is really a set of levels of priority. Things with higher priority need to be done before items with lower priority. For example, top priority, first level of priority, is something called enclosing symbols. Most of you have probably heard this referred to as just parentheses, and parentheses are one type of enclosing symbol, but we're going to encounter some other types before we're done today. Second is exponents. Exponents, of course, include powers and roots. Third, multiplication and division. Remember, multiplication and division are the same operation, just different approach to the same operation, so they happen on the same level of priority. Just like roots and powers are the same operation, combined to make the exponents. And then finally, the lowest priority, the lowest level of priority is addition and subtraction. So we can only perform addition or subtraction if there is nothing else of any other priority, any higher priority to do, or higher level operation to do. So back to our example here, there are no enclosing symbols, no exponents, but we do have multiplication and division. So we have multiplication. 8 times 3 makes 12. So all I'm going to do is replace the 8 and the 3, the 4 times 3, replace the 4 and the 3 with a 12. Nothing else in the problem has changed. Now there's nothing else in this problem that's multiplication or division, so we can go down to the lowest level of priority, addition and subtraction. That's all that's left. Well, there's an addition and a subtraction, and of course, when there's more than one item at the same level of priority, we work left to right, just like reading a book. So 8 minus 12 is a negative 4. And then negative 4 plus 7 is 3. Let's look at something a little more difficult than that. Okay, so looking at this one, just a little bit more complicated. First thing we see is there are enclosing symbols. There's parentheses. In fact, there's two sets of parentheses. Now we said when there's more than one item at the same level of priority, we go left to right. Same here. Left to right, here's the first parentheses we run into. We have to find its mate. That one goes the wrong way. That one just goes back to there. This one at the very end is the mate to that first parentheses. So we have to start our work inside that set of parentheses, inside this blue box, if you will. Now some of you are saying, but there's more inside there. Yes, there is. Now that we're inside that first set of parentheses, our order of operations still applies. So inside that parentheses, inside the blue box, we need to look and see if there are any other enclosing symbols. And that's where we find the second set of parentheses. So we have to start inside that parentheses, inside the red box. Now there's only one thing to do in there. 9 minus 4 makes 5. The rest of the problem does not change. Now that we've reduced what's inside that set of parentheses to a single number, we don't need the parentheses anymore. So I'm going to take them out. Now, since I'm going to assume you guys have done some order of operation problems in the past, I'm going to take some shortcuts here. One of those, the first one, the main one I'm going to take is I'm not going to rewrite the problem every time. I'm just going to do this. I'm just going to start erasing stuff. So I don't need those parentheses anymore. I can just take them out. So now I am back to working in this larger set of parentheses. So in there, I'm still going through my levels of priority. Are there any other enclosing symbols? Well, no, not really. Second, are there any exponents, powers, or roots? And yeah, there's one of each. So we go left to right. We have 3 squared, which is 9. So I'm going to replace that with a 9. I have the square root of 49, which is 7. So I'm going to replace that with a 7. Now there are no more exponents, so we go to the next level of priority, multiplication or division. And there are several, so we're going to start out going left to right. 7 times 6 is 42, so I'm going to take out the 7 times 6, replace it with 42. Now we have 42 divided by 14 right away, which is 3. So I'm going to erase that, replace it with a 3. 2 times 9, replace that with an 18. 56 divided by 7, we'll replace that with an 8. No more multiplication and division. So last level of priority is addition and subtraction, and that's all that's left here. So we go left to right. We're going to start out with 6 minus 3, which is 3. So replace that with a 3. 3 plus 18, which is 21. Take that out, put in 21. 21 minus 8, which is 13. And then finally, 13 plus 5, which is 18. Now we've reduced that set of parentheses to a single number, just the 18, so I don't need the parentheses anymore. But here I have to be a little bit careful. When I take out the parentheses, there is no symbol here between the 2 and the parentheses, and of course that implies multiplication. So I have to put my multiplication symbol in there when I take that parentheses out. And now I'm down to the last couple of steps. I go back to my level of priorities. Notice I take that parentheses out. Are there any other enclosing symbols? No. Exponents? No. Multiplication or division? Yes, we have 2 times 18 is 36. No more multiplication or division. So now it's just addition and subtraction. 9 plus 36 is 45. Now I realize you guys are probably pretty familiar with examples like that, and probably with this next example too. Let's see here. So we'll do something like this. When we look at a problem like this, the key to understanding it is this symbol across here, this line. What does that line mean? Anybody? Okay, divide. Yeah, it does mean divide. It's called a fraction bar. And it does tell us to divide. But it also is an enclosing symbol. It separates part of the problem from the rest. It separates the top from the bottom. So even though it's telling us to divide, it's telling us that first we have to do everything on top, then we have to do everything on bottom, then we can divide. So we're going to start out on top. 21 divided by 3 plus 7 squared. Any other enclosing symbols? No. Exponents? Yes, 7 squared is 49. So you have 21 divided by 3 plus 49. Next, multiplication and division. 21 divided by 3 is 7 plus 49. And finally, we do the addition. 7 plus 49 is 56. So this is 56. Then we go to the bottom. And on bottom, we have to do everything before we can divide. Again, we look for our levels of priority. Enclosing symbols? No. Exponents? Sure are. There's 2 squared. 2 squared is 4. Nothing else changes at this point. Now we have multiplication and division. We're going to go left to right. 14 times 2 is 28. And then 5 times 4 is 20. So now we have just subtraction. 28 minus 20 is 8. So the bottom is 8. Now that we've reduced both the top and bottom to a single number, now we can divide. 56 divided by 8 is 7. There's our answer. So that's another form of enclosing symbol that many of us aren't used to. We might have something like this. Of course, most of you know this symbol to be the absolute value symbol, which is a distance operator asking us how far is that value from 0. That is also an enclosing symbol. It separates that part of the problem from the rest. So we're starting inside that absolute value symbol because it's an enclosing symbol. We have no other enclosing symbols, no exponents, excuse me. So we got multiplication. 4 times 7 is 28. Excuse me. So we have 6 minus 28 inside the absolute value now. 6 minus 28 is a negative 22. Now, just like with parentheses, we've reduced what was inside that absolute value to a single number, so we can get rid of the absolute value symbol. The difference is, in parentheses, we just got rid of the symbol, and we may have to look to see if we need to put in multiplication. Absolute value symbols, when we remove the symbol, we actually have to do something. We have to find the absolute value of what was inside of it. The absolute value of a negative 22 is positive 22. We still, just like the parentheses, have to put in multiplication if there's a number in front with no symbol. So we put in the times between the 7 and the 22. Now, of course, 7 times 22 is 154. 9 minus 154 is a negative 145. Plus 1 is a negative 144. A final type of enclosing symbol I want you to see. Will look like this. We know that's a square root symbol or radical symbol. But in this case, it's also an enclosing symbol. It separates this part of the problem from the rest, which means we have to start inside there. In there, again, we still go through the order of operations. Any other enclosing symbols? No. Exponents? No. Multiplication and division is right there. 9 times 7 is 63, so this is 1 plus 63. Now, we have the addition in there. 1 plus 63 is 64. And just like the parentheses and the absolute value, when we have that reduced to a single number inside there, now we can get rid of the symbol. But order of operations still does apply here, so we have to look back at the bigger problem. There are no other enclosing symbols to deal with. No other no other exponents, no powers or roots that would be to the left of it. So now we can do that square root. Just like with the absolute value, however, when we remove the enclosing symbol, we actually have to do something here. Square root of 64, we're just going to call it 8. Technically, if this were an algebra course, we would say it's 8 or negative 8. But we're just going to go with the positive. And now we have the 2 times, just had to put in the multiplication, just like parentheses. 2 times 8 is 16. 7 plus 16 is 23. So enough with the order of operations. We have one last topic to cover before we call the end of Unit 1 here. This is one of those topics that's kind of lost traction. It doesn't get taught as much as it used to. But in the medical field, it's still used enough that we need to go over it. And that is Roman numerals. The Roman numbering system is much older than the Arabic system that we use. And it's a little bit more primitive. And the Roman numbering system actually came off of the old, basically a tally system, making scratches in the side of a stone or scratches in the dirt to record how many you had. But what they found was, of course, you keep putting these scratches into whatever it is you're using, or these little marks. After so many, it gets to be too much. You have to start counting. It gets to be tedious. So they started grouping them. And we've seen the tally system where you do 1, 2, 3, 4, 5, like that. That was a primitive step in it. But the Romans took it a step further. They came up with symbols for different sizes of groups. So in the Roman system, the I is still just the 1. But then if you went up to 5, they used the letter V for 5. X stood for 10. L was 50. C is 100. If you ever heard the slang term a C note, that's what I was talking about. It's a $100 bill. Above that is D for 500. M for 1,000. Sorry. M also stands for mil, which means 1,000 in the Roman and Greek language. And they keep going from there. That's as high as we're going to go with them. But there is another symbol that was actually new to me when I started teaching this course that I hadn't seen before. It's SS. SS is the Roman symbol for 1/2. Now, I was always taught the Roman letters, for the Roman numbers, the letters had to be capital. Well, that isn't necessarily so anymore, especially in the medical field. You're more likely to see them as small letters than you are as capital letters. The way their system works is they combine symbols then to add up to a number. Like 3 was just, 3 ones put together. 1, 2, 3. 7 was a 5 and 2 ones. I'm just going to put the hash marks for the ones to save some time. They had some quirks, though, and they put into the system. They didn't like writing out 1, 2, 3, 4 like that. They thought that was too much work or too much movement. Now, you got to remember the reason it wasn't as easy for them to write as it was for us. They were dealing with ink and a quill and dipping the pen. So if they could reduce the amount of ink they needed to use, it saved a lot of time. So what they did, rather than doing this and using 4 marks, is they came up with a subtraction system. Here, this is all added together. 5 plus 1 plus 1 makes 7. They came up with a subtraction system. If there was a smaller symbol to the left of a larger one, we're doing subtraction. For example, IX. Well, the I stands for 1 and the X stands for 10. The I is a smaller symbol in front of the 10, in front of the X. So that means that this is not 1 plus 10. This is 1 taken away from 10, or 10 minus 1, which is 9. So for 4, instead of doing 4 hash marks, they did 1 taken away from 5, which is 4. 5 minus 1. There were some catches to this. One, they did not subtract 5s, 50s, 500s. They only subtracted even, powers of 10. 1, 10, 100, 1,000. They would also only subtract one order of magnitude smaller. So this makes for a couple of awkward examples. Let me show you. 46. It would make sense to just do 50, which is L, subtract 5, and add 1. But they don't do that because the V is a 5. They don't subtract 5s. They only subtract orders of 10, powers of 10. So the way they would do that is they did L with an X in front of it. That's subtracting 10 from the 50 to make 40. And then they would add the 6, like this. Another awkward example would be 99. It would make a lot of sense to do IC. 100 minus 1 is 99. But they only go one order of magnitude below the main unit. You can't subtract 1 from 100 because 1 is 10 to the 0 and 100 is 10 squared. That's 2 orders of magnitude. So they'd subtract a 10 from the 100. So XC makes 90. Then they would have to add 9 to that. So an IX to make 9. Again, that's a little awkward. I could think of a lot of ways to make this system more efficient and user-friendly, but that's just the way they did it. So let's take a look at interpreting some Roman numerals, and then we'll take a look at converting some standard numbers into Roman numerals. So let's do CM, LIX. So let's start with this one. We always start left to right. The first symbol is an M. We have to double check, is the next symbol smaller, equal, or larger? Well, the next symbol is equal. So the only time we would have to do anything here is if the next symbol were actually larger than this first one. And it's not. So the M is worth 1,000. This M, we look, the next symbol is smaller, so we're good. That one's worth 1,000. This C, we look at the next symbol, however. C, of course, is 100, and M is 1,000. The symbol after the C is a larger symbol, so that means we have to use those two together and subtract. 100 taken away from 1,000 is 900. Looking at the L, I is the next symbol, which is obviously smaller, so the L is just a 50. The I, the next symbol is an X, which is bigger, so this is 1 taken away from 10, or 9. And now we combine this all together, 2,959. So we'll have M, D, X, C, I, V. So let's go from this one. Start left to right. Here's an M. That's 1,000. The next symbol is a D, which is 500. So we're okay. That 1,000 is followed by a smaller symbol, so that's just 1,000. Now we have the D is 500, X is 10, so that's okay. The D is followed by a smaller symbol, so that's just 500. X is 10, C is 100. That's followed by a larger symbol, so we're going to have to combine the two and subtract. 10 from 100 is 90. I is 1, V is 5. Again, the I is followed by a larger symbol, so we have to combine them together and subtract to get 4. So 1,594. Now, in the medical fields, we don't get into really large Roman numerals like that very often. That is more in the copyright dates. Expiration dates sometimes are written out like that. For example, if you have a copyright that was 2013, or sometimes an expiration date is 2013, you would look at that, and that 2,000, of course, would be M, and another M to get 2,000. 13 is XIII. That would be that expiration date. And that is sometimes used in the medical fields like that. More often than not, however, in medicine, what they're using the Roman numerals for is for calling out the number of grains, the size of a medication. So we might have XII grains of medication. Well, how many is that? Well, X is 10, I is 1, I is 1. Well, X is 10, it's followed by a smaller symbol, so it's just 10. I is 1, it's followed by another I, so they're equal, so those are just 1 and 1, so that's 12 grains. We might have ISS grains. I'm going to leave the word grains off. I stands for 1, SS together stands for 1/2. So that is simply 1 and 1/2. We could have IVSS. I is 1, V is 5, SS combined to be 1/2. Well, the I is followed by a V, which is larger, so we're subtracting. We're going to combine I and V to get 1 taken away from 5 is 4. SS is 1/2, so that's 4 and 1/2. So that's converting from Roman numerals back into standard. Converting from standard into Roman numerals is just as simple. Let's take a look. Let's do 7,892. Well, I'm going to keep under 7,000. We didn't go into the 5,000 symbol, so we'll keep it smaller than that. We'll go 3,892. So we start out with the larger digits. 3,000 is just going to be M, M, and M. 800, we're going to start out with doing 500 plus 3 ones. So 500 is D, C, C, C for the 3 more 100s. That is 500 plus 300 is 800. 90 is the next digit. Notice we don't worry about the 92. We're just worrying about the 9. 90 is XC. That's 9 away from 100. Or 10 away from 100, I should say. That's 90. And then we have the 2 ones. We might have 68.5. Let's convert that. We'll start out with the 6. Well, 60, I would start out with a 50, which is L, and a 10, which is X. Then we need the 8. Well, that would be a 5 and 3 ones, so V, I. Then the 1/2 is the SS. Not so bad. So let's look at, if we were to work with our Roman numerals at all, how would we do that? So we might have something like this, plus MDCC something like that. We can add these as Roman numerals. Now, to be honest, I would recommend, I usually convert them into standard to Arabic numerals and add them together and then convert them back. Tends to make fewer mistakes. I'm going to try to show you an example of adding them as Roman numerals. We'll see if I screw it up, and then we'll go from there. So anyway, we're going to start out looking at the symbols that we can combine here. So we have the M and the M here. I can just combine those because there's nothing after them that are larger. So we have M and M. Here, however, this C is being subtracted. That's actually a negative C there. It's being taken away. I look down in the other number. Is there a spot there where I have a C that's a positive C? And I do right here. So I'm just going to cancel that out. This C and that C are canceled out. So this is now a full M. L, X, and X, those are all positive. This I is a negative. So I've got to look to see if there's another I can cancel out somewhere. Down here there's an I, but that I is being taken away from the 10 there, from the X. So those are both negatives. I can't cancel anything out. I have a D here that's a positive, so I'm just going to put the D down. This C is a positive now. The L is a positive. We'll have X, 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 and X. That's 5 X's being combined together. That'd be 50. That'd be another L. I know I can't have 2 L's. We'll fix that in a minute. Then I have this to deal with. I have the I's being taken away. So I'm going to have to take this V and turn it into 5 1's. And I'm going to cancel out this one. Cancel out that one being subtracted. I now have 3 of them. And I now have another X there that's positive once that I has been removed. And 3 1's, 3 I's. Now I obviously have some work to do. The 3 M's are okay. The D, the C can never have 2 L's together. That just makes another C. So M, 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 D, C, our new C, X, I. Let's do this now with converting it to standard notation, to our Arabic numerals, and see if we come up with the same answer. See how badly I screwed that up. So this is 1,900, 50, 60, 74, 1974. This is 1,500, 600, so 1,630, and IX is 9. We add those together, 13, 11, 16, 3,613. The 3,000, M would be 3,000. 600 would be 500 plus 100, 13. So I got an extra C in there somewhere when I did this. So as you can see, there's a lot of chances of making a mistake here. Let's see where my extra C came from. I'm not seeing it. Did I interpret something wrong here? Nope, so I made a mistake in there somewhere. I will never ask you to add Roman numerals in this course. I wanted to show you an example so you can see it was possible. Obviously, it's very difficult because I screwed it up, but anyway, we'll let it go with that. So much for me trying to show you a little bit extra. Anybody have any questions on any of the stuff we've looked at today? Order of operations or the basic converting between Roman numerals and standard numbers and back again? Okay, that is the end of Unit 1. Just want to give you a quick list of what will be on the test for Friday, just so you're ready. There will be operations with integers, so positives and negatives, fractions and mixed numbers, decimals, and order of operations. These here you will be expected to do without a calculator. If anybody is on an ILP or any sort of learning plan, your facilitator at your school will clear it through them and they'll give you any appropriate accommodations if necessary. Beyond that, there will be rounding. You'll round to the nearest hundredth versus the nearest hundred, the nearest 10. We'll be working with percents. Converting Roman numerals. And of course, the big one that everybody loves, word problems. So that is our big list for Unit 1. After this, there'll still be a little bit of review starting out Unit 2, but hopefully it gets a little more interesting from here for you. Some homework on the new stuff we've looked at, the order of operations and Roman numerals. Order of operations is on page 23, 1 through 21. I'd recommend you probably just do the odds. There would be enough for you. And the Roman numerals, which I would highly recommend you take a little bit of a look at, is on page 39, 1 through 12. Any questions? Okay. For those of you that are interested, by the way, I said that there were numbers larger than the M for 1,000. If you want to get anything larger than that, the way they did it was this. They do an X with a bar. That bar meant times 1,000. So X was 10. That was 10 times 1,000, or 10,000. So then V with a bar over it would be 5,000, and so on. Anyway, I'll let you go. The last 8 minutes here you can have just do your homework or study for your test if you want to. We will see you all on Friday.